Welcome. In this video, we're going to be working on some rational equations, which are equations that involve fractions with x's in the denominator. Okay, but first we need to practice simplifying rational expressions, adding two fractions that have x's in them, multiplying them, dividing them, subtracting them, maybe just simplifying rational expressions, right? And remember that to multiply two fractions, we usually multiply straight across, but in order to add or subtract, we need a common denominator. That's kind of the thing here, at least at first. So simplify the rational expressions. I'll just put these up here and just kind of work on them one at a time, I guess. All right. A is going to be 2 plus 1 over 2x minus 6. Okay, so we want to add these together. We need to have a common denominator. So I need to have this 2 have a denominator of 2x minus 6. So I multiply it by 2x minus 6 over 2x minus 6. And that's 1, right? Just provided x isn't equal to 3, but this expression already wasn't defined when x equals 3, so I'm not even going to really worry about that too much. Plus 1 over 2x minus 6. Then I could simplify this by calling this 4x minus 12 plus 1. So 4x minus 12 plus 1 all over 2x minus 6. And we could call that 4x minus 11 over 2x minus 6. And actually, when we go to graph these things in Algebra 2, we're going to be interested in starting here and moving back there, undoing that. And we actually already know how to do that. I'll just remind you about that when the time comes. All right, for B, 1 over x plus 1 minus 1 over x. All right, for this one, I'm going to get a common denominator, but I have two different denominators, so I'm going to kind of work on each of them. So 1 over x plus 1, I need to multiply that by the same thing on top and bottom. I'm just going to multiply by the opposite denominator. Okay, minus 1 over x, and I'm just going to multiply by x plus 1 over x plus 1. So, when I actually kind of clean this all up, and maybe I'll subtract them with a single denominator, x times x plus 1 there. I'll have 1x minus an x plus 1. So x minus all of x plus 1. So I'm subtracting the x and I'm subtracting the 1. And so this ends up being negative 1 over, and you could distribute this if you wanted to, or you could just leave it as x times x plus 1. I don't think that it's necessarily more simplified if you distribute, because you might end up needing to factor it to determine what the zeros of the denominator are if you want to figure out where this fraction is undefined. But it's going to be undefined anywhere. These two things are undefined. Okay, so let's just move on to C. Okay, I'll do that here. All right, with C, 2x cubed, and I'm just going to, I think this time I'm going to leave room to plus 4x minus 5, just to multiply in the other denominator. That is not going to be necessary. I didn't notice that this one's times. Okay, so this one will be a little easier. So we're going to do 2x cubed times x minus 1 divided by 10x squared. Okay. Now with this one, hopefully you can see that we're going to need to simplify some things. We're going to need to cancel stuff off. The 2 and the 10 are cancelable. The x cubed and the x squared are going to be cancelable. So what I'm going to do is I'm going to kind of put the numbers first, then the x's by themselves, and then I'll put that x minus 1. And I might factor this because I feel like x minus 1 could be a factor of that. So I'll have 2 over 10 multiplied by x cubed divided by x squared multiplied by x minus 1 divided by, okay. Down here, I'm going to factor this thing. Two numbers that multiply to negative 5 while adding to positive 4 would be positive 5, negative 1. So I've got x plus 5. There we go, x minus 1. Okay, and then I might be interested in canceling off some things. Okay, these x minus 1s, they're in parentheses. They're multiplied. They can be canceled. Okay, x cubed divided by x squared. Okay, I would subtract the exponents in that situation if I was just looking at x cubed divided by x squared like that. But, okay, and that's really what we are doing. X cubed divided by x squared, that's just 1 power of x left. And then n is 1 over 5. Okay, so I've got 1x in the numerator and a 5 times x plus 5, so that'll be 5x plus 25 in the denominator. Okay. D is going to be dividing two things. Now, instead of copying the problem and then flipping and multiplying, I'm just going to flip and multiply right now. So it's going to be this times 2x plus 2 over the square root of x. So x to the 5 halves times 2x plus 2. I probably should have factored that, yeah, because I've got that x plus 1 there, but it'll be all right. So, oh, whoops, get rid of that. And I'm gonna, oh, wait, x plus 1 and then the square root of x. Maybe I'll put that x plus 1 here, and the square root of x, I might write that as x to the 1/2 power. Just gonna like rearrange this stuff. And so I'm gonna say x to the 5 halves divided by x to the 1/2. We're gonna subtract the exponents. It's gonna be x to the 4 halves. And then I'm gonna factor out the 2 from 2x plus 2, and I'll be left with x plus 1 divided by x plus 1, and I'll be left with 2x squared. E is just a fraction on its own, and so I'm going to need to factor and hope to see common factors. Let's see, what are we working with here? Okay, the numerator has a leading coefficient that's not 1, and it can't be factored out of the whole thing, so I'm going to be thinking about, and I might bring in a little post-it note or something. Let's say, all right, for this one right here, for the numerator, 2x squared minus 13x plus 15, I'm going to multiply the 2 and the 15, and I'm going to look for two numbers, m and n, that multiply to 30 while adding to negative 13. That feels like 10 and negative 3. No, negative 10 and negative 3. Yeah, that will work. Okay, then I'm going to say, all right, I'm going to split up that negative 13x into negative 10x and negative 3x. But everything else will stay the same. And then I'm going to group and factor. What can I factor out of the first two terms? A 2 and an x. And I'll be left with an x minus 5. And then over here, what can I be factoring out? I can factor out a 3, but I should probably also factor out the negative so that I can get x minus 5 on that. So I'm factoring out a negative 3. I'm left with x minus 5. Then I factor out the x minus 5s. And I have 2x minus 3. Okay, so I factored this. I'm just going to use that result. And if you can do it faster than that in your head or something, then be my guest. But I think that's the most fail-safe way to do it. So I'm going to keep that here. Divide by, okay, x squared plus x minus 30. Two numbers that multiply to negative 30 while adding to positive 1. That would be positive 6 and negative 5. So I'm going to have x plus 6 and x minus 5. Then I can cancel these things off here, and I'll be left with 2x minus 3 over x plus 6. There's not anything I can do more with that, right? Because I need to be able to cancel whole things that are multiplied together, right? With parentheses around them. Can't be like dividing the 3 by the 6. Don't do that. That's cherry picking. Okay, so f is going to be another common denominator because we need to subtract these two things. So I've got x squared minus 4. Okay, and this is a situation where one of the denominators is a multiple of the other, right? Because x squared minus 4 is equal to x plus 2x minus 2. So maybe I'll just write the denominator factored. So I've got 2x plus 15 over x plus 2x minus 2 minus this x plus 3 over x plus 2. So in order to have the same denominator, I need this x minus 2 down here. But I got to be fair, multiplying by something that isn't 1, because that would change the value of the fraction. So I'm going to do that, and okay, this is going to involve some FOILing. So I'm going to do 2x plus 15 minus what I get when I do FOIL here. Right? So, and this is all going to be divided by that common denominator. Okay, so 2x plus 15 minus x squared, add those, I get plus 1x, multiply them, I get minus 6. And then, with any luck, I'll have something that is factorable, and I'll be able to cancel a little more. So negative x squared, 2x minus an x is plus x. 15 minus negative 6 is positive 21. I don't think that's going to be factorable. I don't know of any factors of 7 that add to negative 1, if I factor out the negative. So I'm just going to leave that. and divide by x squared minus 4. And there's no common factors there. There's nothing that's identical in parentheses that we could kill off. And so we're not going to be able to simplify this any farther. Okay, G, let's see, let's fold this. Almost used up this sheet of paper. G is going to be 3 minus 1 over x plus 1. So this is very much like the first one, except it's a subtraction. So I'm going to say, all right, so that's 3 times x plus 1 divided by x plus 1 minus 1 over x plus 1. So I have 3x plus 3 minus 1. Okay, 3x, 3 minus 1, all divided by x plus 1. This is going to be 3x plus 2 over x plus 1. And then h, and there's nothing I can do here. I can't factor out the 3 and then get an x plus 1 exactly to cancel, so it's not going to work. In fact, if I did, then I would get 3, and we know that 3 minus 1 over x plus 1, well, I'm not really sure exactly what it is, but I know it's not equal to 3 because I subtracted something. Okay, so h is the last one, and I don't like I probably said it in class, I don't like layers of fractions. I think they're needlessly confusing. There's always a better way to write it, but I don't know what y'all are going to be confronted with in next year in your next class or on the SAT. I mean, I'm not an expert on this stuff, so I do need to train you on what to do in that scenario. Okay, really, I'm just thinking about numerator up here, divide by denominator. Okay, so the numerator is going to be 2 over x plus x over 4. And if I'm dividing by the denominator, I need to just flip and multiply. So if I'm dividing by this, I'm going to multiply by x over x plus 1. And yeah, I'm not really seeing anything that I can immediately just cancel, mainly because of this addition here. So I need to get this to have a common denominator. So I'm going to say, all right, I would need to multiply by 4 over 4 here. I might just do that in line. And then I would need to multiply by x over x here. So I'd have x squared plus 2 times 4 divided by 4x multiplied by x over x plus 1. Okay. And now the x plus 1 and the x squared plus 8, there's nothing I can really do with that. Okay, the 4, there's no whole number multiplied by anything that I can cancel off with, so I'm going to just call that 4. Wait, x squared plus 8, pardon me. 4 times x plus 1, but then I have this times x, and I also have this x down here. So I can cancel those off and be left with x squared plus 8 over 4x plus 4. All right. Okay, now we're going to find the values of x that make the equations true. And that will involve us, I'm going to need some more paper, maybe combining with a common denominator or something, but a few sheets for this. So maybe some cross multiplying. Okay, this looks like kind of a mix. So, all right, over here. 12 over x plus 3 over 4 equals 3 over 2. Kind of my recommendation with this is if you see 3 different denominators, let's just get a common denominator and then clear the whole thing out. If it's easier to get, if there's only 2 denominators, you could combine them and cross multiply. With this one, I don't think that's going to be the way to go. Okay, so if I've got an x, a 4, and a 2, I'm just going to multiply all that together. 4 times 2 is 8x. And so I'm going to say 12 times 8 over 8x plus 3 times, okay, I would need to multiply by 2 and an x here, divided by 4 times 2x is equal to 3 times, okay, I'll need to multiply by 4x on top and bottom to get that common denominator of 8x. And now that I've got a common denominator, I can clear it all out. And I don't think I really did this in class. We didn't encounter any equations that looked like this where this was probably the best course of action. But what I'm really doing here is I'm taking both sides of this equation and I'm multiplying it by 8x. And that's fine, right? I am changing the value of these fractions because I'm not multiplying by a fraction that's 1. But I'm being fair to both sides of the equation, which is one of kind of the core principles of this class. So we can solve equations by being fair to both sides, doing operations to both sides until we kind of whittle it down. Okay? But the 8x can cancel with the 8x here. And if I distribute this in over these, then it will kill off these 8x's. And really what I'm doing is just killing off the entire denominator. I'm left with 12 times 8 is 96. Yeah. And 6x equaling 12x. So then I subtract 6x from both sides. And I get x is equal to 96 divided by 6. And I don't know about you, but I don't just immediately know. I think it's going to be 16, I think. But what I'm going to do is I'm just going to say, okay, dividing by 6 is like dividing by 2 and dividing by 3. So I'm going to divide 96 in half first. That's 48. And then divide 48 by 3, and that's something I know how to do. That's going to be 16. I think maybe at some point I knew that 16 times 6 was 96, but it was best to be certain. Just by going at it step by step. All right, so that was A. This will be B. This is one where we're just going to cross multiply, right? Fraction equals fraction, just cross multiply. X times x plus 10 is going to equal 4 times x squared minus 2. Okay, so I've got x squared plus 10x equaling 4x squared minus 8 when I distribute everything. And then I'm going to set this equal to 0 and solve, right? Because I'm trying to solve a quadratic. So this is going to be 0 equaling to, I'm going to subtract an x squared, subtract 10x, and then I still have minus 8 here. Oh, this is factorable. Okay. Now, if you want to just go straight to the quadratic formula here, that's an option that you have. Okay. That always works. It solves every quadratic. That's why we developed it in the first semester. But this thing is factorable. I'm looking for two numbers that multiply to negative 24 while adding to negative 10. Oh, no, it still works. I was thinking 6 and 4, but 12 and 2 also works. So I think it's going to be, negative 12, positive 2. So I'm going to split this up just like that, negative 12x plus 2x, and then everything else will stay the same. This is the second time we've done this in this homework, so I'm going to go a little faster. Group and factor. And minus 4. Be left with 3x plus 2. And then I'm going to say, all right, this is still equaling 0. Okay, so these things would multiply together and equal 0 anytime where this equaled 0 or that equaled 0. Okay, this thing will equal 0 and x is equal to 4. If you're unsure about this, just solve it out. 3x plus 2 equals 0. Subtract 2 from both sides. Divide by 3. Okay, and we've got our answers. Now, at this point, rational equations can bring back extraneous solutions. So I'm just going to give it a quick glance at the original equation and make sure that I am not doing anything illegal, right? So x can't be equal to 0 right here. X can't equal, I guess, the square root of 2. We weren't trying for x to equal that, so we're safe with respect to extraneous solutions. All right, the next one here, so let's bring it back. C, x over x plus 2 plus x equals 5x plus 8 over x plus 2. This one, I'm pretty close to a nice common denominator. So I think I'm going to get this one a common denominator, and then I'm just going to clear everything out. It's going to be the way to go. So I'm going to just copy the problem real quick. X over x plus 2. And that's going to equal 5x plus 8 over x plus 2, right? In order to get a common denominator, I took this x and I multiplied it by, some special form of 1 that would be beneficial to me. So I'm going over here, and what am I going to do here? I'm thinking, I'm going to clear out the denominator. That's why I got the common denominator here, was so I could do that and say, all right, this x plus x squared plus 2x equals 5x plus 8. Because really what I did was I multiplied both sides by x plus 2 and I cleared out that denominator. Okay, so then I'm going to have x squared minus 3x. I'm going to set this thing equal to 0 by subtracting 5x. Whoops, I still have that x there. And I guess I'll subtract an 8, and that's equal to 0. I need to write this a little more nicely. Negative 3x plus an x is negative 2x. This one's factorable too. I was kind of hoping one of these, I bet one of these comes back unfactorable, and we'll have to use the quadratic formula. Okay, two numbers that multiply to negative 8 while adding to negative 2 would be negative 4 and positive 2. Meaning that x is going to either equal 4 or x is going to equal negative 2. Okay. Let's off the side. D. Oh, okay. Yeah, this is one where I think some strategy would be helpful. So 1 over 3x minus 2 plus 5 over x equals 0. Okay, you know, so often in this class we solve equations and we start by setting them equal to 0, and this one's already set equal to 0. I'm going to actually say we undo that. I'm going to say let's like subtract the 5 over x from both sides. And so I would have negative 5 over x over there. If I have fraction equals fraction, I can cross multiply. I like that. That's what I'm going to do. Okay, so I just set up so that I could cross multiply. Now you could have gotten a common denominator and cleared out the bottom if you wanted to. And it's going to be equivalent to the work I'm doing. And whatever you think you should do first, that's what you should try, right? Always. Don't just rely on whatever I'm doing. You should do these things the way you see fit. So I'm going to cross multiply. That's x equaling negative 5 times 3x minus 2. Okay. So I'm going to add the 15x to both sides. I'll have 16x. That'll be equal to 10. And I'll divide by 16. If I have 10 over 16, that's like 5 over 8. Okay. And that's great. Okay, well, that was D. Okay, so the next one's E. 6 over x minus 1 equals 4x plus 2 over x plus 1. All right, yeah, I recognize these because I saw a few of these out there. You know that 6 is equal to 4 plus 2. And somehow if we're having like different denominators, it's going to be really hard for 6 to equal 4 plus 2 in this way. And so I'm expecting to get no solution here. I'm not saying it's impossible for these equations to return a solution, but I'm going to need a common denominator here. So what it's going to be is the common denominator will be x minus 1, x plus 1, x plus 2. So what I'll have is 6, and so what I'm missing here is x plus 2, x plus 1. And then equaling 4 over x plus 2. Okay, I need to get a common denominator, so I need the x minus 1 and the x plus 1. But wait a second, if I multiply x minus 1 times x plus 1, that's x squared minus 1. So that'll help me with the, when I go to simplify this. And I know that this is the same as that because x squared minus 1 can be broken into these two things. Plus 2 over x plus 1, okay, that's going to need to have an x minus 1 and an x plus 2. And this one's going to be a little involved. Okay, so 4 times x minus 1 times x plus 2. Now, this is one where I'll say, if anybody knows a better way to solve this one than what I'm doing right here, like, please let me know. I would love to hear about it, but I'm not really seeing anything else fast to do here. All right, so but now that I've got the common denominator, I'm going to clear it out. I'm going to get rid of it. I'm going to multiply both sides of this equation by x plus 1, x minus 1, and x plus 2. And so I'll have 6 times x squared plus 2x plus another x is 3x and 2. And that's going to equal 4x squared minus 4. Plus 2 times, all right, x squared plus 2x minus 1x minus 2. All right, so I've got 6x squared, 18x, and 12 equaling 4x squared. Okay, I'll just distribute that to, whoops, almost. Okay, whatever. Don't need those parentheses there, but I put the back one in, so I'm going to go put the front one in too, I guess. All right, so I got 6x squared plus 18x plus 12 equaling 4x squared plus 2x squared is going to equal 6x squared. Negative 4 minus 4 is negative 8. And that's plus 2x. Oh, okay, so this is going to have a solution. Okay, so I subtract the 6x squareds. Okay. And I get, and maybe I'll subtract 2x as well. 16x plus 12 equals negative 8. Subtract 16x equals negative 20. X equals negative 20 divided by 16. Both of those are divisible by 4, so I might call that negative 5 over 4. Okay, now, I just still feel like I might have made an error there. Just kind of quickly looking around. I don't know. Okay. I guess really if I wanted to check, I could plug in 5/4 in here, but I don't want to do that. Okay, I'm just going to take it on faith. It's only homework, right? It's a pretty low stakes opportunity to make mistakes. All right, 5 over x minus 5 equals x over x minus 5 minus 1. Well, I'll just call 1 x minus 5 over x minus 5. And, okay, we are going to need to be careful when we subtract that after clearing out the denominator. But I'll have 5 equals x minus 5. Oh, this is a good one. Okay, so 5 equals x minus x plus 5, so that's saying 5 equals 5. Okay, that means all real numbers. Say that this equation is true as often as 5 is equal to 5. Okay, that will give you all real numbers. I'm just kind of proposing that if we go back to the way that f was written up here, this equation isn't going to be true when x is equal to 5. Right, because we're dividing by 0, and neither of these things are defined, and undefined can't be equal to undefined. That's not going to work. Okay, so this is all real numbers except for x equals 5. So I'm just going to say x is not equal to 5. All right, G, this is another one that's going to be pretty annoying. Maybe I'll try to think of a way to go about this a little faster. So 1 over x plus 2 plus 1 over x minus 2 equals 3 over x plus 1. Okay. Yeah, so when I go and actually combine these with, oh no, what I'm going to do is I'm going to call this, yeah, let's combine these with a common denominator, and then cross multiply. That might have been the faster thing to do on the other one on E. Yeah, that definitely would have been faster. Get a common denominator of the second. If you've got 3 different denominators, to get 2 of them put together and then cross multiply, I think that's what I'm going to do here. So let's see. I'll put in all my steps. Yeah, so let's call this x minus 2 over x squared minus 4, because what I need to multiply in is an x minus 2 over x minus 2, and if I have x plus 2 times x minus 2, that's going to be x squared minus 4. Minus an x plus, or I guess that's going to be a plus, yeah. Plus x plus 2 over x squared minus 4 equals 3 over x plus 1. Yes, this is going to be the way to go. So if I add these two things together, I'll have x plus x is 2x, negative 2 plus 2 is 0. Oh yeah, I'm loving this. Equaling 3 over x plus 1. Yes. All right. So cross multiply. 2x times x plus 1 is going to equal 3 times x squared minus 4. Okay, I'll have 2x squared plus 2x equals 3x squared minus 12. I'm going to subtract the 2x squared and the 2x, I guess, and set it equal to 0. So I can hopefully factor, but I'm thinking 2 numbers that multiply to negative 12 and add to negative 2. 6 and 2, no. 4 and 3, no. 12 and 1, no, not working. Okay, I have to use the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so this is going to be 4 plus 48 is 52. That can be reduced like into simplified radical form, but you know, I think for our purposes here, 2 plus or minus the square root of 52 divided by 2 is going to be just fine. I think you can call that 1 plus or minus the square root of 13. But, you know, if you want to do that, be my guess. Okay. H. A lot of equations on this one, but that's what y'all need. So H is x over 6 plus x minus 9 over 3x equaling 3 over x plus 1. Wait, no. I was copying the wrong one. That's 1 over x. Yeah. Okay. So I'm going to go for a common denominator, and I think this will be the type where I want to just like clear it out. Because I'm going to go for a common denominator of 6x. So I'm going to say x squared divided by 6x. I'm multiplying by x on top and bottom here. Over here, I'm going to multiply on top and bottom by 2. So I'll have 2 times x minus 9. That's 2x minus 18 over 6x. And I'm going to need to multiply by 6 over 6 here, so that'll be 6 over 6x. Then I clear that out, and I've got x squared plus 2x minus 18 equals 6. Let's subtract 6 from both sides and get x squared plus 2x minus 24 equaling 0. So what would be two numbers that multiply to negative 24 while adding to positive 2? That would be 6 and 4. It would be positive 6 and negative 4. Okay, and I'm going to get x equaling negative 6 or x equaling positive 4. Okay, I realize I've been doing a lot of these and have not been checking for extraneous solutions. Obviously, neither one of these are going to be. Let me look at my last sheet of paper that I was working equations on. Let's see. Okay, got a fraction, got everything except for 5, got an irrational number. That's probably not going to be it. Just making sure with the first few, x equals 4. I don't think that was ever a denominator issue. Oh, yes, I found one. Okay, part C. One of our answers was x equals negative 2. That's extraneous. Okay, pardon me, I completely slipped up and forgot that can happen. And I know I tried to put 1 on the homework where it happened. At least I caught it now. Okay, but you know, in the middle of working, you know, between H and I. Okay, there you go. That one was extraneous on C. Okay, I fixed my error now. Neither of these are extraneous because they don't cause our original equation to divide by 0. Okay, I will be 4 over 3x plus 1 equals 2 over 5x. Okay, yeah, I tried to make sure that these really long sets, ended up getting easier at the end. So 4 times 5x is 20x, equals 2 times 3x plus 1 would be 6x and 2. So I'm going to subtract 6x from both sides. Then I guess I'll divide by 14, and I'll get x is 2 over 14, which is the same as 1/7. Okay, J, the last one, 9 over x squared minus 16. Okay, and again, checking for reasonableness. Okay, that's not going to cause either of our denominators to equal 0, so we're good. That's going to equal 1. So I multiply both sides by x squared minus 16. Now this one only has one power of x in it, so we can solve directly, and I think that's what I'm going to do. I'm going to add 16 to both sides and say, oh yeah, 25 equals x squared. So I take the square root of both sides. Don't forget the plus minus. X equals plus or minus 5. Neither one of these caused a division by 0 in the original, so these are both valid solutions. Okay, that was a lot of equations, but I think it's going to get faster from here because I've just got 3 situations for you to deal with. So I'm going to bring the problem set back in. Say, all right, solve the problems involving direct, inverse, and joint variation. Okay. If x and y vary directly, with y equaling 8 when x equals 2, okay, then that means y is equal to some number times x, and y is equal to 8 when x is equal to 2. So that means that k has to equal 4. So y equals 4 times x. What's the value of x when y equals 6? 6 equals 4x. X equals 6 divided by 4, which is the same as 3/2. With B, y varies jointly with x. That's something we talked about in class, And I don't know if you have any experience with this. It's not something I'm going to put on the quiz or the test, but I don't know where it fits in. But joint variation is just like direct variation. Okay, jointly with x and z means like that. Okay, direct variation with x and z. Okay, maybe not. Maybe we shouldn't be doing joint because that would be like, too many variables. But whatever, we can do it. So y equals 12 when x equals -2 and z equals 3. So -6 times k equals 12. That's telling me k needs to equal -2. Then it'll say find y when x is 4 and z is -1. So y is equal to -2xz. And then I'm going to say, all right, find y when x is 4 and z is -1. So I'm going to have +8. For c, if a varies inversely with b, that means a is some number divided by b, or b is some number divided by a. You could work it out the same way. It would give you the same answer. And a equals 3 when b equals 5. Okay, that's going to multiply both sides of this equation by 5, and ck is 15. So a is 15 divided by b, or b is 15 divided by a, or a times b equals 15. Some people will tell you for inverse variation that the two variables are multiplied together to equal the same number every time. But that's not how we're going to do it. We're thinking about rational functions, so we're going to think about variables in the denominator. The a is 2.5, so 2.5 equals 15 divided by b. Okay, so I'm going to multiply both sides by b, and I'll have 2.5b equals 15. And, maybe you don't know how to solve this equation, or you don't know how to divide 15 by 2.5. Something you could do is you could double both sides of the equation. 2.5 times 2 is 5b equals 15 times 2 is 30, and then you could divide both sides by 5 and say b equals 6. Okay, on D, u and w are varying inversely, so u equals some number divided by w that we're about to find out. U equals 7.5 when w equals 6. Okay, so k is going to equal 6 times 7.5. Okay, well, 7.5 times 2 is 15. Okay, and 6 is 2 times 3, so I'm going to need to take 15 times 3, and that'll equal 45. I don't just know what 7.5 times 6 is. I would have to think about it. So that's how you would think about it. And generate that without, a calculator or taking the time to go on the internet and open up a new tab and, consult the Oracle Google for something like 6 times 7.5. Okay, no, there is no e, but I'm not done. Find the value of u when w equals 10. So u equals 45 over w, which is 10. Okay, 45 divided by 10, that's going to be 4.5. All right, now number 4 is kind of an applied context scenario. Okay, the cost to print X paperback novels is $350 for each book plus $1,000 for the labor and machine rental. Okay, so this is very much like one of the problems. Ow, that hurt. This is like one of the ones we did in the notes with the cost for the sandwiches on the bus for your activity. All right, so linear function to model the total cost. C of x is going to equal the fixed cost, $1,000, plus 3.5 times the number of books. 3.5 for each book. Okay, so that's A. B, what is the cost of printing 8,000 books? So C of 8,000 is equal to 1,000 plus 3.5 times 8,000. But maybe I'll do 3.5 times 8 times 1,000. Keep the arithmetic manageable on myself. Okay, I say, all right, that's 1,000. 3.5 times 8. I don't know 3.5 times 8, but I know 3.5 times 2. 3.5 times 2 is 7. I'd have 4 remaining, so I'd multiply 7 by 4 and get 28. And then 1,000, that's 28,000. So 28,000 plus another 1,000 is going to be $29,000. Okay. And then, if the publisher has a budget of $8,000, how many books can they print? Okay, well, that's when the total cost equals $8,000. Okay, so 8,000 equals 1,000 plus 3.5x. Oh, this one's going to be very solvable without a calculator. I was a little worried. I'm going to subtract 1,000 from both sides. Okay, so what would I multiply 3.5 by to get 7,000? Well, I multiply 3.5 by 2 to get 7. I'd still need to multiply by something to get up to 7,000, so it'd be 2,000. So x equals 2,000 books. Okay. D, write a rational function to model the average cost per book when printing x books. Okay, well, the average cost is the total cost divided by the number of books. So it's going to be the c of x function divided by the number of books, which is x. Okay. How many books would I need to print? So what value of x gives me average less than 5? So let's just find how many books would give me an average of exactly 5, and then we say more books than that will push the cost down. Okay. So we're interested in where a equals 5. So 1,000 plus 3.5x divided by x is equal to 5. So I'm going to multiply both sides by x, or you could look at it as 5 over 1 and cross multiply. But either way, I'll have 1,000 plus 3.5x equals 5x. Then I'm going to subtract 3.5x, and I'll be left with 1.5x. But I might be better to write that instead as 3/2 x. So I'm going to start by multiplying both sides by 2, and then dividing by 3. So 2,000 divided by 3, that's going to be 666.667 books. So I think if we made 667 or more books, then the cost would be under $5 per book. And what was I thinking? Oh, yeah, when we made 2,000 books, the cost was $8,000. That's an average of $4 per book, and that is more than 667 books. Yes, that's it for that one. And yeah, that's all the room I've got on that sheet. So the intensity of sound varies inversely with the square of the distance between the source of the sound and the observer. Okay, that's another thing I didn't exactly tell you about in the lesson, but most of the true inverse variation things that happen in like science or the natural world are actually inverse square. A lot of things like sound, light. I'm not a scientist, so I'm not really thinking of it. I'm sure like, the force of a magnet, that's going to diminish with the square of the distance. Okay, so what I'm saying is that intensity of the sound, okay, I guess I'll call that N, the intensity of the sound, varies inversely with k divided by the square of the distance, and I'll call that distance x. So I'm going to define the variables off to the side just to remember. Intensity and in units. Okay, yeah, because really the true nature of intensity of sound, I don't know, it got me confused when I was reading up on it to write this problem, and so I just decided I would just call it units. Intensity and x is distance. Know what we're measuring distance in, maybe we'll figure that out as we move on. In meters. Okay, write an equation for the intensity of the sound in x meter distance. 4 meters from the source of a sound, here's the intensity of 10 units. So 10 equals k divided by 4 squared. So that's 16, multiply that over. K is going to be 16 times 10. All right. Then I'm going to say, all right, now my full-blown formula is N is 160 over x squared. If the observer moved to 2 feet from the source, what would be the intensity of the sound? So N would be 160 over 2 squared is 4. Well, 160 divided by 4 is 40. Okay? So when we went to half the distance, the sound was 4 times as much, and that's the inverse square thing. If we were to go to a third of the distance, the sound would be 9 times as loud. And if the observer moved to 12 feet from the source, what would be the intensity of the sound? So x equals 12 will give me n equals 160 divided by 12. I don't think that divides cleanly, does it? Hold on a second. Yeah, I'm not going to worry too much about it. It's 160 divided by 12. I'm just going to keep reducing. 80 divided by 6, 40 divided by 3, tripled, so we should divide by 9. I did not square. Okay, that makes a lot more sense. So that's, okay, pardon me. I was like, what is going on here? 160 divided by 12 squared is 160 over 144, which is 80 divided by 72, which, wait, both of these numbers are divisible by 8, so 10 over 9. Yeah, which is what I was expecting. When we go 3 times as far, the intensity of the sound should be 1/9, the inverse square law. Okay, so I get 10 divided by 9. That makes a little more sense. Okay, if the observer was carrying a baby and needed to get to a place where the intensity of the sound was less than 2 units, how far would they need to go? Okay, so that's intensity is less than 2. N less than 2. And then, okay, yeah, this is the type of rational inequality we're going to solve in this class. We're not going to do a whole lot of it. N is equal to 160 over x squared. All right, is less than 2. Now I'm going to multiply both sides by x squared. That's going to be completely fine because x squared is not going to be a negative number. So I've got 160 is less than 2x squared. Divide both sides by 2, and I got 80 less than x squared. Take the square root of both sides, and I'm going to get x is greater than the square root of 80. 80 is divisible by 16, I think, so I think that's going to be 4 square root of 5. I feel like, again, I've messed this up. No, that's right. No, that feels right. Okay, so x needs to be greater than 4 root 5 meters. Okay, so, you know what I know would be a safe distance if you were carrying a baby that would be greater than this is 4 times 5. It's 20 meters, right? Can't ever be too careful with your hearing. All right, I guess that's the moral of this homework. Be careful with your hearing, and thanks for watching. Hope this